In physics, you'll see lots of questions like this where you have to calculate the tensions in the two cords that are holding a uniform rod. So this tension here and this tension there. There are lots of ways to do this question. You could get involved in taking lots of components and setting horizontal and vertical components, etc. And that will work, and it's very satisfying. It's that you'll have half a page of algebra prone to lots of mistakes. So I'm going to show you the easy way, which kind of goes back to when you were 14 years old. And there is going to be the weight, which I'm going to call 800 newtons. So what we're going to do is pull out these vectors, tension 1, tension 2, and see what we can do with them. But just to point out, we have a third cord here, but we're interested in forces acting on the plank. And of course, this string up here, this rope, is not connected to that plank, so it doesn't play any part, so we can just forget it. Okay, so let's pull out the vectors and see what happens. So first of all, this here is T1. And we know that T1 is at an angle of 50 degrees to the vertical. Let's pull out T2. And what a lot of students do is put the two ends together like that. But of course, going back to your earlier school physics, you know you can't do that. It has to be tip to tail. So there we go, tip to tail. And we know that this angle to the vertical is 40. Lastly then, let's bring in the 800 newtons. Now we know that if this forces, or if these forces I should say, are in equilibrium, then this triangle has to end, be a closed loop. Now of course it didn't the way it still doesn't. I need to make my arrow bigger, but it's okay for me to do that because I haven't drawn a scale diagram, have I? So I can make this forces any size I like. But what we do know is it represents 800 newtons. So now it's just a question of using some simple algebra. So we know that the cosine of theta is always the adjacent over hypotenuse. So let's look at T2, which is this bottom one, which we know is going to be equal to the adjacent. It's adjacent to the 40. So we know that it's going to be equal to the hypotenuse, which is 800, times the cosine of 40 degrees. And T1 then, by a similar argument, is going to be 800 times the cosine of whatever that angle is. Well, if this one is 40 and that's a right angle, this one here must be 50. So T1 is therefore going to be 800 cosine 50. Earlier on I worked these out then, so that T2 becomes 613 newtons and T1 is 514 newtons. So you could just leave it there, but it's probably a good idea to just check your work. And because we've got our right angle triangle here, we can say that if we take 613 and square it and add it to 514 and square that and take the whole root of those two added together, that should of course equal 800. And when you work this out, I believe you get 799.9, which, as I'm sure you'd agree, is basically 800. Like I say, the algebra way is great, it's good fun and it's good to practice, but heck, this is an awful lot easier.